a couple things. If you are going to use this to do the homework starts way down here. Couple things. This, let's see. Yes, 13, 14, 15. Notice there's no coordinate plane axes drawn in. You would just take, and I don't even care if you don't redraw this. The book says take this, redraw it, and put it on here, and then draw the translation also. You don't need to do that. Just once I teach you how to do this, you'll see this tells you where to go with it. Put this in a place that makes sense so you can still move this amount. You may put it wherever you want, but draw your own axes in where it will make sense, okay? And then there was one other thing. These ones. This one, you're going to fall off of the grid that is there. Just draw little lines in. Just make it fit. It's all good. Or just do it on your own graph paper. That's fine too. Okay, here we go. Not there. Here we go. We are talking about kind of the big picture today, but then also starting on the branch offs of that big picture. So big picture today is transformations. Within transformations, there's a few different types, and we are going to talk about the first of the transformations for the second half of the lesson today. So, starting with a transformation itself, we say a transformation is a mapping that results in a change in the position, so where it is, position, or shape or size of the figure. Okay, so it can undergo a transformation. You know, you think of like, what's that show? The Biggest Loser, right? They undergo a transformation. So they looked like one thing and they became something different. Either a change in their position or their shape or their size would be a good example for those ones. So the three transformations that we're going to focus on are the three that you see below here. A flip, which the more like technical term for that is to reflect, a reflection. A turn, which is really you're rotating something, okay? So rotation, we will learn. And then a slide, which we call a translation. And that's the one that we're going to focus on today, is the translation. But these are the ones that big picture, chapter 9, you're going to be working with. So a flip, there will be some like line of symmetry that you're flipping over. So a flip might look like this. It's not the only place you could flip. You can flip a lot of places. But this would be a flip. It just flipped over that line. Same shape, still the triangle, but it flipped over, okay? The second one that you can do is a turn, also a rotation. So if I just turn this so that it looks like this instead, okay, that's one type of transformation. And then the last one, which I think is the easiest one, is a slide. It doesn't even change like orientation or the tilt of it or anything. It just slides to a new spot. So it was here, it slides down, and now it's here. Whoops. Okay, so slide or translation. Okay, so with these, there's a few terms that you're going to see that you need to know what they mean. So the first one, we're talking about a preimage and an image, okay? The preimage, what do you suppose the preimage is? What is pre? The first, it's the starting, okay? So the preimage is the original figure that we're working with. Okay, so in the case of what we did above here, these would be the preimage, right? Your original figure. Okay, the image then is the resulting figure for whatever transformation we undergo. So the resulting figure, or you could say it's the newer figure, the new figure that you come up with. So your image would be the greens up here. Okay. So pre-image, first, image, what it becomes. All right, then the third definition, this one doesn't show up a ton, but you do have a few questions about this, is a rigid motion. And a rigid motion, it's just a transformation that preserves distance and angle measure. Okay, in other words, we're saying a rigid motion is going to be the same size figure. So like, for instance, if I'm saying I started with this triangle, and then it became this triangle. If they're the same size, it is a rigid motion because the distance between these 2 points is the same as the distance between those two. The distance here is the same as the distance here, and the distance here is the same as the distance here, and then all of their angles are the same. So this angle is the same as that angle, and the other two sets of angles are also congruent. Okay, so if it preserves distance and angle measure, it is a rigid motion. So let me just show you in this example what I mean by that. This one asks you, does the transformation appear to be a rigid motion? So look at A. You have your preimage, you have your image. Would you say that's a rigid motion? Does it preserve distance and angle measure? Yes, right? If they are the same size and the same figure, we would say yes. So this would be yes. You can say they're the same size, or you could say preserves. You don't need to do both of these. Distance and angle measure. Okay. So what about B? Is that a rigid motion? No, because your distance between them changed, right? The angles are still the same. Those angles are congruent, those angles are congruent, but now your side lengths, this length and that length, are not the same anymore. So we would say no, this is not, because it's a different size. Okay. So some of the terminology and symbols that you're going to see in this chapter, one of them is the phrase maps onto. So they'll say like triangle ABC maps onto triangle DEF. Maps onto is just an arrow. When you see an arrow, you think maps onto. Okay. The other one is prime. If you start with a point A, so like if I'm looking at, let's go up here. In letter B up here, if I call this point A, they would probably just call this point A prime. So when it has that little like apostrophe, that's said prime, okay? So I would say A maps onto A prime, okay? It became that new point. So I'm going to show you in example 2 here what that looks like. We would say in this case, and you needed to write these letters in because we don't have them in here right now. If this is ABC, and this is A prime, B prime, and C prime, okay? It says up here that triangle ABC, what do you say for the arrow? Maps onto triangle A prime, B prime, C prime. Okay, so the one triangle, the first triangle maps onto the second triangle. What are the images? Do you remember what the image was? What did we say for image? Not pre-image, the image. The resulting figure, the new figure, okay? So what are the images of angle A and angle B? So what is the image of angle A? What is the new corresponding part? A prime, okay? So the images of A and B would be A prime and B prime, right? A became A prime, B became B prime. And then we're just going to name corresponding sides to make sure that everyone's clear. You guys have done this a million times over, so it shouldn't be anything new other than now there's a prime associated with it, which actually I think makes it easier, right? Because now you don't have to match up ABC with DEF. You match up A with A prime and B with B prime and C with C prime, okay? So your corresponding sides would be that segment AB, maps onto, you could say, segment A prime, B prime. You don't have to do the maps onto. You could just put an and in between. So BC would map onto B prime, C prime. And then AC would map onto A prime, C prime. Okay, so you're just matching up corresponding parts, which, like I said, you guys have done this time and time again. That should not be anything terribly new. Okay, so that's kind of the like broad overview, vocab, things you need to know about transformations, okay? Now we're gonna get a little more specific. So we're gonna start with the different types of transformations and then just go into one of them today. So the 3 types, and I already listed these for you above, but now I'm gonna give you the math name for it, which I also gave you up top. One is translations. Okay, that's the one I said earlier, we call it a slide. You're just translating to a new place, you're sliding to a new place, so a translation. The second one is a reflection, which means you're just flipping. Okay, and then the third one is a rotation. Do you remember what the word was for a rotation? Turn. There's a little bug on my podium. Ew. Sorry. Okay, so we're going to talk translation today. We're going to talk about the slide, where we go with a translation. So the definition here is a translation maps all the points of a figure the same distance and the same direction. So if this is, for instance, if we look at these 2 triangles, let's call this triangle ABC. And this other one then is going to be A prime, B prime, C prime. Okay? What it's saying for a translation is that you move the same amount for every set of corresponding points. So if I'm going from A to A prime, okay, this length here is going to be the same length as B to B prime. So these 2 lengths are congruent, and same thing for C to C prime. Also the same length. So the amount you move is identical in a translation, in a slide. It does, in this case, make a rigid motion. In other words, the 2 triangles are exactly the same. If it wasn't a rigid motion, they wouldn't move the same amount. So a translation like this will be a rigid motion for what we're going to do with it. That means angle A and A prime are the same, C and C prime are the same, and B, God bless you, and B prime are the same. But it also means all the side lengths are the same. So this AB is congruent to A prime, B prime, AC and A prime, C prime, and then BC and B prime, C prime. Okay, you don't necessarily have to mark all of that, but just important to know they move the same distance. Okay, so I'm going to show you kind of how they're going to write the rule for a translation. We always say, what's the rule? There's translations. They're going to use a letter for their rule. So translations use a capital T. Reflections use a capital R, and rotations, because it's another R, is a lowercase r. So you're just going to have to get in the habit of writing a rule using their letter. So we're talking translations right now. So we're going to use that capital T. Okay. And then we need to see where this translation is going to go. So I'm going to draw you 2 triangles. You're welcome to draw them on here with me, and if that's helpful to you. One of our points is going to be at -2, 1, 2, 3, 4, -2, 4. I'm just going to zoom in real close on this. -2, 1, 2, 3, 4 is this point here. We're going to call that point A. And then from there, just drop down 3 points, 1, 2, 3. So at -2, 1 is point B. And then move to the right 2 points, and that's going to be our point C. Okay, so we have this triangle. Okay, Okay, that is our preimage, right? That's the one we started with. Our image from there is going to be the point 3, 1, 2, 3, 1. Okay, this is going to be my A prime. And then B prime, you can just go the same distance. 3 down from there is B prime. And 2 to the right from there is C prime. Okay, so we are trying to come up with what rule got us from triangle ABC to triangle A prime, B prime, C prime. In other words, how did we move there? Now, if you think about it, for me to get from A over to A prime, think of it how we always move on a coordinate plane. We start with our X, right? So we're going 1, 2, 3, 4, 5 to the right. And then we're moving 1, 2, 3 down. Okay, and if you were to try it from any other point, it would be the same thing. From B, 1, 2, 3, 4, 5 to the right, 1, 2, 3 down. From C, 5 to the right, 3 down. So it doesn't matter which points you pick. Here's what matters. Here's where people always make the mistake on this one. They go, oh, I'm going to start at C, and I'm going to see how far I had to move to get to my other triangle. And they go from C, and they stop at A. You cannot do that, okay? When you're trying to figure out the rule, you have to go from A to whatever its image is, which would be A prime, okay? If you're going to start at B, that's fine, but then go to B prime. If you're going to start at C, that's fine, but then go to C prime, okay? Don't go from A to C or B to A. It doesn't work that way. Okay, so if this is my setup, and we said we went 5 right and 3 down, you write it like this. Basically, we're saying it's our X value plus 5, and it's our Y value minus 3, okay? So when you write a translation, we're gonna do a capital T, and then you do these like pointed brackets. It's called a vector that we're showing. So the pointy brackets, and then we're gonna go 5 to the right is a positive 5, and 3 down is a negative 3, okay? And then we write of triangle ABC is triangle A prime, B prime, C prime, okay? When they ask for the rule, this is the rule. Because the beautiful thing is you can do that to any of your points and get to the right end point. So rather than have to say, I did this point plus 5 and minus 3, and then go to a different point plus 5 and minus 3, this is just saying every point goes 5 to the right and 3 down, okay? So just remember, this is your, where did you move on your x-axis, and this is where did you move on your y-axis. Questions on that? Okay. Let's try it. So this one, they're giving you the rule, and you have to come up with where are you going to end up. So let's say we graph this first. So 3, 3 is our A. 1, 2, 3, 1, 2, 3. That's point A. B is 5, 1. 1, 2, 3, 4, 5, 1. C is 1, 0. Okay, now you have a couple options here. They're going to tell you to do a translation of negative 3, 4 for this triangle. Some of you are going to prefer to graph it, and others of you are going to prefer to do the math with it. And I don't care which one you do, but you typically end up having to do the graph to prove your results. So it might just be easier just to graph it. I think it's easier just to graph it, but it's up to you. So if this is the triangle I'm starting with, and we're doing a translation of negative 3, 4, where am I moving? Where is negative 3, 4? 3, not down. Left 3. up 4, right? So if this is negative, you're going left 3. This is positive, you're going up 4. So just keep in mind your first one is your left and right. Your second one is your up and down, okay? So I could right now just do this. I could go from A, 1, 2, 3 to the left, 1, 2, 3, 4 up, and get my A prime right here. And then come over here and say the translation of A is 0, 1, 2, 3, 4, 5, 6, 7. Okay, I could just tell what that point is. If you don't like that route, you can do the math to figure it out. So if instead you want to say, no, I want to use just the points. A translation of negative 3, 4 of B, you take your point B, which is 5, 1, and you do the math to it, right? So the 5, you have to subtract a 3. The Y, the 1, you have to add a 4. And it would put you at B prime, which is 2, 5. Okay, so you could do the math, or you could graph. Either way, you're going to end up, if I go, let's see, 3 to the left, 1, 2, 3, 1, 2, 3, 4. Here's my B prime. And then for C, 3 to the left, 1, 2, 3, 4 up. Here's my C prime. You should end up with those 3 points as your image. Okay, your pre-image is the purple, your image is the red. We want to know where did you end up. So we ended up at 0, 7, 2, 5, and then for point C, again, you can just name that point, negative 2, 1, 2, 3, 4, or you can take point C and do the math. 1 has to subtract 3, and 0 has to add 4, so I end up at negative 2, 4. Okay, totally up to you which one you want to do, but typically you will have to graph it regardless. Okay? Questions on that? Okay. Yes, ma'am.
Will it ever ask us to not graph something?
Yeah, like this next example, you're going to get the graph and just have to tell me the rule. But the graph is not on here. So you guys are going to have to graph it with me right now, but that's just because it's really hard to put the graph on here. So you guys are going to do that with me. Okay, example 4. What is the rule that describes the translation that maps these triangles onto each other? I should have put the other letters on here. L prime, we're going to give you. M prime, we're going to give you. And N prime, we're going to give you. So L prime should be 2, 2. M prime is 1, 0. And N prime is 4, 1. Okay, so I'm going to do these as 2 different colors. I'll do black and blue, just how you see them. Go ahead and plot those points right now, okay? So L is negative 4, negative 1. M is negative 5, negative 3. And N is negative 2, negative 2. So there's our first triangle. And then L prime, M prime, N prime, you have 2, 2. You have 1, 0. And 4, 1. You just leave it there. Thank you. Okay, so the question is, are you still graphing? Need a minute? Okay, I'm going to write a little pointer down for you while you finish graphing. You have to make sure on these that you start at the pre-image. Okay. Which figure is my pre-image? The black one, right? There's a black one and a blue one up there. The black one, the one that doesn't have the primes, is our pre-image. That's our starting point. You have to start from there, okay? It's going to be very tempting on your quiz and your test to start from the other one and then you'll do it exactly backwards of what it's supposed to be. So just be careful with that. You always want to start at the one that does not have the primes on it, okay? Okay, so the question is, what is the rule to describe this translation, okay? That right there is the first key to your rule. What letter do you put at the front of a rule that is a translation? A T, okay? So we're going to say this is a translation. And then you do your pointy brackets. Okay, now this is where you have to do the work to figure out where did we go. So if I'm starting from point L, where am I counting to? L prime, right? So from L, I need to get to L prime. Now here's the other place a lot of people will make a mistake. They'll go, oh, I'm going up 3 and to the right 6. So it's 3, 6. Do you know what's wrong with that? You started up instead of left to right, right? We want to start with our X value and then do our Y value. So from here, we're going to go 1, 2, 3, 4, 5, 6. Okay, so it's 6 to the right. That's positive. And then we're going 1, 2, 3. Is that positive or negative? Positive. So it's a translation of 6, 3. And you could check that. If you went from N to N prime, it's still 6 to the right, 3 up. If you went from M to M prime, 6 to the right, 3 up. So it doesn't matter which one you pick. They're all going to be the same. Okay? So we would say it's a translation of 6, 3 of triangle LMN becomes triangle L prime, M prime, N prime. Okay, questions on that? Hopefully. Okay, last little thing here is what's called a composition of transformations. And this is just when you have 2 or more transformations happening at the same time. So there's a problem here. It says Carmen leaves her apartment and travels 2 blocks east and 5 blocks north to the library. Then she travels 4 blocks west and 1 block south to the grocery store. Where is she in relation to her apartment? Where would you say is a good starting point on this graph? 0, 0. I would start at 0, 0, okay? So we're going to say right here is her apartment. Okay, I'm just going to call it A for apartment. It says she travels 2 blocks east and 5 blocks north. What point are you at if you go 2 points east and 5 north? 2, 5, right? 2 to the right, 5 up. 1, 2, 3, 4, 5. So she gets here, and she's now at the library. Okay, I'm just doing L for library. It says then, so where are we starting this next step from? From L, okay, she got to the library. Then she travels 4 blocks west and 1 block south to the grocery store. So from there, 4 blocks west would be what direction? To the left. So we're going 4 blocks to the left and 1 block south, so 1 block down. And we end up here at the grocery store. Okay, now this part's easy to mix up. It says, where is Carmen in relation to her apartment? Okay, so where is she currently, but in relation to her apartment? So she was at her apartment here. So from her apartment, she is where? Okay, but use like direction for me, right? We're saying where is she in terms 2 blocks?
5 blocks north, 2 blocks west.
Right. So she is 2 blocks west and 4 blocks north of her apartment. Okay? So that's what you would say. She is 2 blocks west and 4 blocks north of her apartment. Okay, it's tempting there to say she is 2 blocks east and 4 blocks south of her apartment, but she is not, right? 2 blocks east and 4 blocks south of her apartment is down here. So make sure you pay attention to the wording. In relation to her apartment, where is she? She is currently 2 blocks west and 4 blocks north. Okay? Any questions on that? Okay. You do eventually need your protractor in this chapter. You need it for the first time on Monday. So make sure that if you've lost it, that you find it before Monday and bring it with you on Monday. Like I said before, if you want to do the homework right on this set of notes, you are welcome to do that. If you want to just do it on lined paper and get some graph paper for the graphing parts of it, that's fine too. I don't care. But if you're going to do it right on here, it's all there for you. So it's pretty convenient, I would say.